You also have another helium flow here that just goes to the GC. You know, it's not doing anything, but when you switch into the inject mode, you've now got the helium from the sample is going to the vent, and the helium from this side, this other helium flow, is actually flushing the sample to the GC column. Removed, water's removed again, and then it goes into the sample
and
split.
This is the sampling.
Yeah.
And the previous one is flushing.
So it's load. So you're loading the loop.
Yeah.
So so the flush bit is completely different to this, because the flush does not come here. It's cut. So if you use the flush needle,
right,
it just goes to atmosphere.
Oh, okay. Oh, okay. See.
So you just flushing the tube out.
The helium goes to the sample vial and
Goes out to atmosphere.
Yeah.
Okay. Whereas in this case, the sample actually goes into that line.
Yes. Yeah.
Can you show the sample flow path with the...
So the sample flow path, it's going to be a little bit different. So you've got helium coming through. It will come out the bottom of the needle, and then you have a hole at the top of the needle, so it will push the mixture of the helium and whatever's in there back into. It's not drawn well here, but what I would say, so you've got your sample, your helium comes into your needle here, it'll go into the tube, flush the tube out, it'll come back down this line here, and this, you can pick this up here, so it actually comes down the capillary and then goes into the first naphion. It will then go into that 8-way valve, so if you want to have a look at it there. Yeah, and it'll go through the loop and then empty to atmosphere. So it'll continually do that. It's got a slow flow rate, so it just keeps flushing, and then after a period of time, you then switch it. So the helium flow from here now just goes to vent, but the helium flow from here now actually goes back into the loop and then flushes it towards the GC column.
So the sample is...
So you've got 100 microliter loop there, so that's filled with the mixture that comes from here.
It's split.
Pardon?
The sample gas split.
Yeah.
Part goes to here. Part just vent to.
No. So if you look here, in this case, so you're diluting it with helium because you're pushing helium through the system. But it's helium mixed with your sample, and that will come through here, and then it will fill the loop. So that's filled. Any excess will go to atmosphere, but this is a mixture of the helium and the sample. The excess is just keeps going, but then in a very, very quick, short time, that's how quickly it turns, and then the helium now pushes that 100 microliters of gas sample plus your helium into the GC column. Okay. And that'll separate your nitrogen from your CO2, and then you've got your H2O trap, your naphion again, to remove any more, and then you will go into open split where there is some dilution, and that will then go into your mass spectrometer.
So this part is like a dynamic reservoir.
Yeah.
You keep 100 microliter samples there.
Yeah.
During the first stage.
Yeah.
And when you change these 8 points,
So it'll go.
you trap that 100 micron, then goes to the next.
But at the same time, this is still flushing through. So your sample is being diluted. It's a very small amount, but it's being diluted. So by the time it loads the second sample, let's see if I can get you some data to show this. Lab books. CO2. All right, gas banks. So you can see the sample is getting smaller and smaller, and that's because it's continually being diluted with the helium. But what you'll see, let me try and alright, let's get that there. Okay, so you can see the values, they're changing slightly over time. But if you take the average of that and then compare it with the average of the standard, it's being treated in the same way, so it has the same depletion.
Right.
And therefore you can actually, so this is what one of the things we do. We take 5 of these samples, we take the average and we do the standard deviation of the average.
Okay.
And then, you know,
in the loading mode, so are you just accepting some loss of sample as it vents through vent 2? No. What am I
yeah, you are going to lose some sample.
Okay.
But so it's flowing at a specific rate.
Yeah.
So you're going to get a mixture of your CO2 and your sample, CO2 and your helium.
Right.
But then it's going to switch. But then when it's switched in the inject mode, it's still continuing to go through vent 1. So it's still flushing out sample and your. So it's flowing in the same way. You know, you've got the same flow, the same pressure. You get this. It's the same dynamic. You know.
Yeah. So in the load one though, like so you're pushing material through this, and you're basically just filling this up.
Filling that up, and then,
so that when you switch it, it'll continue on through here.
Yes.
But then as you're doing that, while it's in load phase, this like front matter, is it going to vent out and you're going to lose some sample?
You're gonna put more than 100 microliters through that.
Okay. Nice. Yeah.
You're gonna put maybe 150 microliters.
Okay. And then once this is full and you switch it to inject, what is the mechanism that continues pushing this now that you're not connected to this?
It's this helium.
Oh,
You've got a different helium
okay,
flow.
I understand now. Okay.
So both the load and inject mode are for sample, not for flush. Which is
No,
what I was
no,
confusing.
purely for samples. So you load it, then you inject it, then you load it, then you inject it, and you repeat 10 times.
Okay.
But as I showed you in this, it gets smaller and smaller because it's becoming more and more dilute. But there is a difference, but it's not a huge difference.
And the correction for the samples will be against your reference material.
Which you will treat in the same way.
Yeah, assume their fractionation occur in the same way.
Yeah.
Cool. You guys can explore the gas bench later.
Yeah. Okay, so yeah, that's the how the method works.
We can work with reference material. Let's see. On that shelf. We have
Right.
contaminants.
Leak checking. Okay. Because you've got two